Hello, welcome to Engineers Mindset. So in today's class, we are going to be talking about heat transfer. Now, what is heat transfer? Heat transfer is actually the exchange of heat between two bodies which are physically in contact or not in contact by virtue of the temperature difference between the two bodies. It could also be between two or more bodies, either in contact or not directly in contact. Now, there are basically three modes of heat transfer. The first mode is heat transfer by conduction, second mode is by convection, and the third mode is by radiation. So we're going to be talking about these three modes of heat transfer and the mathematical equations that govern them in this video. The first mode is heat transfer by conduction. Okay, conduction. Heat transfer by conduction is simply the heat exchange between two bodies which are physically in contact with one another when the bodies does not experience any form of motion or movement. So the bulk movement of the medium involved during heat transfer is actually zero. So there is no displacement, there is no acceleration, and there is no velocity of the bodies involved in heat transfer by conduction. Heat transfer by conduction usually takes place majorly in solids and not in liquids or gas. So it takes place majorly in a solid body because a solid body is actually a body which is stationary and does not move. So heat transfer majorly takes place between solid bodies. Okay. Now the law that governs heat transfer by conduction is simply the Fourier's law. Okay. Simply the Fourier's law. And this law states that the heat transfer between two stationary bodies is directly proportional to the area of the bodies and to the temperature gradients of the bodies in contact. Okay, so simply mathematically, heat is directly proportional to the area and to the temperature gradients minus the T all over the X of the bodies involved. Okay, so if we remove the proportionality sign, of course, we always introduce a constant. So this simply implies that heat transferred is actually minus K A times dt all over the X. Now, this minus the T dx is called temperature gradient. The negative sign there implies that heat is actually lost by the body or the solid body as there is always a heat exchange between those two bodies. There is always a heat loss from a higher temperature to a lower temperature. Hence, the negative sign. Okay. So the value of K stands for what is called the thermal conductivity. Okay. K stands for thermal conductivity. Okay. And the unit is in watts per meter Kelvin, or most textbooks also use watts per meter degrees Celsius. That's the unit of K. Okay, temperature, the T simply means difference in temperature. All right, so the X also means difference in the thickness of the body. You can simply write that the T is actually T1 minus, okay, T2 minus T1, which is difference between the final temperature and the initial temperature, while the X is difference in the thickness of the body. Okay, it can be called thickness of the body. Okay, thickness, and it's simply x2 minus x1, difference in thickness of the body. And the T, of course, can also be called temperature difference. Okay, temperature difference, and A stands for the area of the body in meters squared. Okay, where Q is the heat supplied, okay, in watts. So the mode of heat transfer by conduction, the law that governs the mode of heat transfer by conduction is actually Fourier's law. And Fourier's law simply would have this equation. So if we simply put in this formula into this equation, we are simply going to have that the heat transferred Q is actually equal to minus Ka into, in place of the T we said is T2 minus T1, it simply becomes T2 minus T1 all over x2 minus x1. And of course, if this negative sign comes into this bracket, we are simply going to have that Q is now equal to Ka into minus times T2 becomes minus T2, minus times minus here becomes plus T1. So I'll simply have here T1 minus T2 all over X2 minus X1. So this becomes the heat transfer between a solid body. So always take note, whenever heat is transferred between a solid body, the heat transferred is always the thermal conductivity of the body times the area, and the difference in the first temperature minus the last temperature, always, because the first temperature must always be higher than the last temperature involved in the process of heat transfer. Okay, so that is that for heat transfer by conduction. Let's talk about the next method of heat transfer, which is the convective method or convection. Okay, so the second method of heat transfer is by convection. Convection is the process of heat transfer between two bodies when there is movement of the medium involved. When there is movement of the medium involved. So when there is movement, you are simply talking about that the mediums involved during heat transfer must always exhibit motion. So there is acceleration, there is displacement, and there is also what? Velocity. And such a situation are what we can find in large water bodies like the ocean, the sea, or even in gases. So the heat transferred in waters or in large water bodies, or heat transfer in fluids majorly, is actually what? Convective heat transfer. So while conduction takes place in solids, convection takes place in what? Liquids or in fluids. Okay, and the law that governs heat transfer by convection is simply um, Newton's law of cooling. Is simply Newton's law of cooling. Okay, Newton's law of cooling, and that law simply states that the heat transfer between a fluid is directly proportional to the area of contact and to the temperature difference. So heat transfer in a fluid is directly proportional to the area or surface area and then to the temperature difference. So you can simply call this Ts2 minus Ts1. Okay, temperature at state 2 minus temperature at state 1. Okay, so if we remove the proportionality sign, of course, we'll always introduce a constant. We simply have Q to now be equal to H AS into Ts2 minus Ts1, where H stands for the convective heat transfer coefficient. Okay, H stands for convective heat transfer coefficient, convective heat transfer coefficient, and is measured in watts per meter squared Kelvin. Okay, it's measured in watt per meter squared Kelvin. And of course, Ts2 minus Ts1 is actually change in surface temperatures. Okay, change in surface temperatures. And AS, of course, area is simply the surface area AS, and Q is actually the heat transferred itself. Is actually the heat transferred. Okay, so heat transferred by convection usually takes place in liquid bodies, and these bodies must be in motion. So it can take place in a gas, it can also take place in liquids like large water bodies such as the ocean, rivers, and co. Okay, that is where heat transfer by convection can be experienced. The final mode of heat transfer is simply radiation. The final mode of heat transfer is simply radiation. Radiation is a mode of heat transfer in which there is no physical contact between the two bodies where heat is being transferred. Radiation is a mode of heat transfer between two bodies which are not physically in contact with one another. So its heat transfer is propagated by electromagnetic waves. Okay, so in radiation, the two bodies can never come in contact with one another. For instance, if I bring a candlestick that contains if I bring a candlestick which contains heat, this is a heat, and if I bring this candlestick close to a stainless steel, okay, let's say I have a stainless steel here. Okay, if I bring this candlestick close to a stainless steel, after some time, as this heat is being dissipated by the candlestick, what happens? the stainless steel would radiate the heat even without being directly in contact with it. If you touch the stainless steel after a while, what happens is that it start feeling hot. So you feel the steel to become very hot, even without being physically in contact with the heat. So that mode of heat transfer is actually called radiation when the two bodies are not in contact. Even the sun rays, we feel the heat of the sun from as miles as we are on Earth. Okay, the rays of the sun see as that a high intensity of heat on us, even as far as we are from the sun. That is another mode of heat transfer called radiation because we are not physically in contact with the sun, but we can as well feel the heat of the sun. That mode of heat transfer is called radiation. So the two bodies which are experiencing this heat exchange are not physically in contact with one another. This heat is being propagated by electromagnetic wave. Now, the law that governs heat transfer by radiation is actually called Stefan Boltzmann's law. Okay, it's called Stefan Boltzmann's law. Stefan Boltzmann is called Stefan Boltzmann's law, and the law simply states that the heat transferred between two bodies which are not physically in contact with one another is directly proportional to the area of the body and to the fourth power of the temperature. So heat transferred is directly proportional to the area of the body and to the temperature, and temperature to the power of 4, to the fourth power of the temperature. So as always, if we remove this proportionality sign, we introduce a constant. Therefore, heat supplied is now equal to, or heat transferred is now equal to sigma A to the power of 4, where sigma stands for radioactive heat transfer coefficient or heat transfer coefficient by radiation. Okay, so sigma stands for heat transfer coefficient by radiation. Okay, sigma equals heat transfer coefficient by radiation, and of course the unit is actually measured in watt per meter squared Kelvin fourth. Kelvin to the power of 4, that's the unit of sigma. Okay, it can also be called the Stefan Boltzmann's constant, and it has a value. Okay, it can also be called Stefan Boltzmann's constant. Okay, Stefan Boltzmann's constant, and of course it has a value. I think I'll look up the value and I'll put it down in description below, but then it has a value of its own. Okay, area, A stands for area, temperature of course stands for temperature, and Q stands for the heat supplied. All right, so heat transferred by radiation is actually governed by Stefan Boltzmann's law. All right, guys, so I think I'll pause the video here. This is as much as we have about the modes of heat transfer: conduction, convection, and radiation. In the next videos, we'll start applying all these laws to start solving problems that pertains to each of these modes of heat transfer. Thanks, guys. I will see you in the next videos. Cheers.